My name is Mark Riedesel. I'm here to present my project for CSCI E-63. I chose to do a project on D3 data visualization, a topic I had requested be added, and I was very pleased that they did. D3 is written entirely in the language called JavaScript. JavaScript is a scripting language, of course, that was created by Netscape in the mid-90s to allow web pages to be more dynamic. It's based on Java, Perl, awk, scheme, self, and hypertalk. An excellent brief overview of the basics of the JavaScript language are in Speaking JavaScript by Axel Rauschmeier in the first chapter of that book, and the rest of that book is actually an excellent reference for the entire language. If you really want to use D3, you have to understand JavaScript, and I found it was different from other languages I'd used. It has what's called uplifting of variables and functions, so that even if you put the list of variables at the bottom of your code, they end up as though they're listed at the top. All numbers are floating point. It has unusual scoping, and it uses anonymous functions to try to control that. And then it has both statements and expressions to control flow. Part of JavaScript now is JSON, which is a data format that's rapidly replacing XML for some applications. And both the NoSQL databases, MongoDB and Couchbase, rely heavily on JSON and use JavaScript as their main programming language. So JavaScript's an important thing to know. And it's very helpful if you want to really master D3. D3 was developed at Stanford University in their visualization group by a PhD student named Mike Bostock, a professor named Jeff Heer, and a master's student named Medig Ogavetsky. Bostock, who now works for the New York Times, remains the lead developer of that. I learned D3 by reading from cover to cover the book Interactive Data Visualization for the Web, Introduction to Designing D3 by Scott Murphy. That's the same book that the professor in our course based his lecture on, which I thought was an excellent introduction to D3. D3 is often learned by example, that there are lots of pages on the web, several pages on the web that have lots and lots of examples. Some of them actually have the code listed with them as well. So that if you want to do something in D3, often the first place to look is to go to the web and see if you can find an example that's similar to what you want to do. To start out with, I'll show some examples from Murray's book on what D3 can do. One of the first ones he had was just a simple scatter plot. As you'll see, that's what I wanted to do. With D3, you can update the values, so you can get this dynamic behavior. To get this nice sort of moving around of the points, you have to have your arrays have exactly the same amount of points in them. So that's a little difficult to do sometimes. You can have axes with annotations on. You can also make the radii of the points different and assign meaning to those, which we'll be doing in this project. And the other thing that I like is you can do these tooltips so that you can have specific information pop up over specific pieces of your data. And I also wanted to do that. So to make the visualization that I'm constructing, we combine different of these features together into what we want. So what I decided I wanted to do was to make a D3 interactive version of a plot that a colleague of mine, Alessa, had made a year ago or so on the tuition versus graduation rate for four-year colleges and universities in the United States. That what he found was that for three different types of institutions, for public institutions, and then private for-profit ones, and then private not-for-profit ones, graduation rates were varied tremendously, and also the tuition varied. So he found that there were expensive private schools that did very well. There were inexpensive public schools that did very well, but almost all of the for-profit schools didn't have very high graduation rates and hence weren't a very good value. He also assigned meaning to the radii in these points. In this particular graph, it's the amount of Pell Grant money that an institution receives. He also did another one in which it was the enrollment. So I wanted to make an interactive version of this. There are several more years worth of data from 2002 to 2010. And also I wanted to be able to interactively change the meaning of the radius. So I went about learning D3 to do that. The data for this project comes from the National Center for Education Statistics. It's a huge spreadsheet of about almost 1,000 columns, 960 some columns, and about 75,000 rows with information on higher education between the years 2000 and 2010. To interpret this, there's also a data dictionary that you can download that tells you what each of those like 960 some columns are. I wrote a Python program to extract the data. I just wanted a few columns on the institutions, the tuition and the graduation rates, and it was very easy to do that with Python. I'll show you the code in just a second. So I created, for the data processing, I made it so that each year between 2002 and 2010 had a separate data file. The data I included was the year, institution, location, enrollment, Pell Grants, tuition and graduation rate, and a couple other things. I did this for public four-year colleges and universities, for private not-for-profit colleges and universities, and for private for-profit colleges and universities. And each of these three categories is shown on the final graph in a different color, just as Al did in his original plot. So what I wanted to do was to make an interactive plot where I could select a year from a drop-down menu and then redraw the graph with the new data, select the meaning of the point's radius, either have it be just a point for each institution, the amount of Pell Grant money it got, or its total enrollment, and then redraw after you made that selection. And I also wanted to have a tooltip to identify the institutions, because that's one of the main things that's missing on the static plot, that you can't tell which institution is which unless you really go and look it up. The starting point often for D3 visualizations is that you find one that's similar to what you want to do. So I just went into Google, typed D3 scatter plot, and I found this, which shows different types of breakfast cereal, and it has many of the features that I wanted. It's a scatter plot, it has different colors for different types of data, and it has tooltips, although I like the tooltips on the bar graph I showed you earlier better. But the nice thing about programming in general in D3 is that you can combine the features you want and create the sort of graph that you want. So the code for this, which is here on the page, was the starting point for what I did for my visualization. So as I said, I wanted to create drop-down menus to select and redraw the data. It turns out that in order to do this, you have to make sure that your data has a unique key, just sort of like the primary key for a database table. You can do this by combining different rows, and I combined the year and the institution name to do this. I can thank my colleague, Sean Gervais, here at McGraw-Hill Education, where I work, for telling me that you had to do this. I would never have figured that out on my own. And then to show the increase in tuition over the years, more dramatically, I held the axes constant so that you could see the increasing tuition. It increases going down the page. As you go from 2002 to 2010, as you'll see, the tuition just keeps getting greater and greater. I also wanted to have it so the radius of the points had a meaning. One is for the total amount of Pell Grants. That's government money that students get just for free to go to college, that each institution has. Also then another choice would be the total enrollment. And also if you just wanted to, figure out which institution was which, I made it so that you could just have plain points. So let me show you the code for these two things. To extract the data, I wrote this Python code. It basically just reads in each row, splits up the 960 some elements, and then just picks out the elements that we want. It reformats it a little bit in some cases. It makes the graduation rates into percentages. It converts all the numbers into strings so you can plot them. And I changed the name of the columns just to make them a little bit easier to understand, although they're still somewhat opaque. The actual code, the D3 code that I used to plot this was based on the code that I got from that, but I had to change a number of things. I added code here at the top to create pull-down menus. I had to divide the code up into functions so that I could have just parts of the graph redrawn when I selected from these functions. And then I also had to add the code to do things like even just format the numbers in the tooltips, and I added a background to the tooltips to make them easier to see. So programming in JavaScript I found to be different from many of the other programming languages I used. I found it challenging, and I came away with a much greater appreciation for what the Java developers who work here at the company that I do for a living. So, and as you can see, the total code is like about 300 some lines. So one thing I found is that I wanted to have this, since this is a web page, basically all you have to do to download the code and run it to show that it runs is particularly easy with a web application. All you have to do is go to the web page and click, put in that URL, and if the page appears and you can interact with it, you've downloaded and run my code. One easy way to put it on the web is to load all the code into a GitHub repository with a particular name. That is your GitHub repository name.github.io. It's a facility called GitHub's Pages, and that's what I did. I set it up so then I could go and run the code. And I'm having trouble with having a little trouble with our firewall, but I've got this set up anyway. So here's what it looks like. So this drop-down menu lets you go from 2002. We can step through the data all the way to 2003. Just go each year. You can see the tuition increasing as we go down the page. It's surprising to me how much the tuition at the private institutions increased over just a 9-year period. And you can also see then the radius of these points have meaning. In this case, it's the total Pell Grants. This is the year 2010 we're looking at. And then I added these tooltips. I like to have a white background so you could see them more easily, as opposed to the tooltips that were on the original template that I used for this. One of the interesting things you can see is that in 2010, the University of Phoenix Online got almost $1 billion in Pell Grants. And what this allows you to do is if you go back, say, to 2006, you can see they didn't get much. They didn't get nearly as much. If you go back even further, it's less. If you go back to here, in 2002, it doesn't even exist at all. The other thing you can do if you go back to 2010 is that we can also change the meaning of the radius. Now it's the total enrollment. So for example, the University of Phoenix has about 380,000 students. One of the interesting things you see here is between 2009, the enrollment at the University of Phoenix goes from just 300,000 up to 380,000. But if we now switch to Pell Grants, the Pell Grants go from 600 million roughly up to almost $1 billion in just a year. So what we can see from this is that using the D3 interactive visualization, we can explore the data in ways that we couldn't before. We can easily identify the institutions with the tooltips. We can look at different years. We can look at the different meaning for the radii. And I would say the last one is I just made it constant. This lets you go and identify the institutions with the tooltips if you need to do that. A feature I wanted to add, but didn't really have time to, just in the press of things as these things go, was to have it so that I could have a search box and I could then search through the page, search through the institutions, have it maybe highlight a particular institution. Also, the 2011 data is available, but it's in a different format, so I didn't have time to go get that. And if you can align the data from year to year so that in the array into which you load the data, the same institution is in the same numbered slot, you can do the very cool D3 transitions and watch the points move around, sort of scurry around the page in the way that we did at that first demo, and I also just didn't have the time to do that. Overall, though, what I found is D3 is a very cool way to construct interactive visualizations. interactive visualizations do help significantly in data exploration. You can see things you couldn't see otherwise. But to go very far with D3, you really need to learn JavaScript. That the people that do JavaScript programming where I work put a lot of effort into learning it. They're always eager to see new features both in D3 and in JavaScript. D3 is in its early stages. It's only existed since the middle of about 2011, and I think it's quite likely that it will become easier to use as time goes on. But even now, it's an extremely useful tool, which I certainly intend to continue to use as time goes on. Thank you.